All right, hey Algebra 2 family. So really quick, happy finals week. So that's coming up next week. Remember, you've got to have your, if you're gonna be online, you've got to have your face showing with your video on, okay? So you got to make sure that you take it during the time frame that we allot for you. You can't just take it whenever, so just keep that in mind. So make sure that your video works before Tuesday, okay? So here's the different AKS that you're going to be tested on. There are 8 different AKS and there are 21 questions. Okay, yes, they're multiple choice. Some of them are select all, so you just kind of have to keep that in mind. But it is multiple choice. So these are the breakdown. We've also made a super cute file folder of all of your videos for each of these AKS and in each unit. So if you want to utilize that, I'll show you probably in the next video where that's at. But let's go ahead and get started. Now, I didn't make a hard copy of this, so you are going to have to write this down on a piece of paper. So in number 1, it says a to the third plus b to the third. What could be the factors if a plus b is one of them? So what that's asking for is a plus b times what will give you a to the third plus b to the third. Okay? And so the best way to do this is you're going to have at least have an a squared up in the front, because a times a squared is going to be a to the third. And then you're going to also have to have a b squared in here, because b times b squared is going to give you b to the third. Now, if we multiplied this out right now, there would still be something else going on in here. Okay? So the actual, this right here is the sum of cubes. So there's actually a formula for that you must kind of already know. And I'm going to show you that in just one second. All right, so this is the little identity that you should probably have memorized. But that being said, this minus AB. So really, in order to make sure that there's no like middle term in here, you're going to have a negative A times B, okay, to make that happen. Okay, so this is called the sum of cubes, and there is a question that is like this on there. If you ever get confused, just take the answer choices and actually like multiply them out, and that should tell you a lot about what your answer is. Okay, cool. All right, on number 2, it says which will be a real answer if simplified. Now remember, real answers are number answers. Complex or imaginary answers, okay, they're going to have an I and then they're going to have a real part, or they're going to have an I only, okay, and that'll be imaginary number. So with this one, I'm going to distribute, so that'll be 25. 5 times negative 4i will be negative 20i. 4i times 5 is going to be positive 20i, and then 4i times negative 4i is negative 16i squared. Okay, so the next step is to combine our like terms, and so we've got negative 20i plus 20i, and those are going to cancel out. Okay, so I'm going to rewrite this. So I'm going to have 25 minus 16i squared. Now, we were told back in the day that I squared equals negative 1. Okay, so I'm going to take negative 1 and plug it in for this I squared. So I'm going to get 25 minus 16 times negative 1. And so that's going to give me 25 plus 17. Okay, and then I'm going to add those two together, which is going to give me 42. Did I really make that 42? That's great. All right, so is that a real answer? Yes, because it is a number. Okay. All right, trying part B. Trying part B. And if I'm going too fast, you obviously can pause the video and then go back. That's totally fine. All right, so I'm going to distribute. And 3i times 5 is 15i. All right, so now we're going to combine our like terms. And so we've got 10 plus, we got 8i plus 15i, which is going to give me 23i plus 12i squared. Okay, so now we're going to plug in negative 1 in for I squared, okay, just like what we did in the last problem. So this is going to give me 10 minus 12 plus 23i. And so that's going to give me, I'm sorry, this is a mess, negative 2 plus 23i. Now, that is not real because it's got this imaginary part in here. Okay, so not real. So continuing with the complex numbers and imaginary numbers, so we're going to select all that are true. So this says I squared equals I to the fourth. Okay, and a lot of us struggled with this on the test. So remember, I squared equals negative 1. Okay, so if I have I to the fourth, then that's really saying I squared squared. So that's negative 1 squared. So that's positive 1. So that would be 1, and this would be negative 1. So is 1 equal to negative 1? No. Did I mess that up? All right, so this is not going to be true. All right, on the next one, you've got the square root of negative 2 equals 2i. All right, so on the left-hand side, we would pull out that negative, so we would put an I out front, and we would be left over with the square root of 2. Well, is this equal to this? No. On the last piece, we've got square root of negative 4. So if we take the square root of 4, we're going to get 2. And that negative underneath the radical is going to give me an I. So is 2i equal to 2i? Yeah. So this one is correct. On number 4, we're going to multiply complex numbers. So we've got 5 minus 3i times 4 plus 7i. So we're going to distribute. And you can do the box method on this one. I'm just using FOIL because it's easier in my eyes. So I'm going to get 20 plus 35i and negative 12i minus 21i squared. I'm going to combine my like terms. And so I got 35i minus 12i. And so I've got 20 plus 23i minus 21 times negative 1. And why am I sticking that negative 1 in? Because I've got an I squared chilling right here. Okay, so this is going to be 20 plus 21 plus 23i. So that will give me 41 plus 23i. Okay. All right, on number 5. Okay, so it says, what are the roots? Now, we need to have a conversation about what roots, solutions, and zeros are, because a lot of people mess this up. This is like basically AKS 54, and a lot of y'all struggled on this. Okay, so what are the roots? Okay, so if I graph this, I would get x squared minus 5x minus 6, and I'm going to hit graph. All right, I see that this is a quadratic, okay? So that means that if this is a quadratic, I'm going to look at my exponent, and my exponent is 2. That means I have 2 possible solutions, okay? However, when I look at my graph, and it crosses, I'm going to take a picture of this really quick. Sorry. And it crosses the x-axis. The x-axis is the real one, okay? X-axis is the real. So we got 2 real solutions, right? And so they're asking what are the roots going to be, okay? So we're going to look at where it crosses the x-axis. So going back to my calculator, I'm going to hit second graph, or you can just look at it on the graph. But we've got an x-intercept or 0 or root, which is 6. And then we have one that is at negative 1. So our roots are 6 and negative 1. Well, let's talk about complex really quick because a lot of people struggle with that. If I had something that looks like this, well, first of all, this looks like a hot mess. Second of all, I want to think through, all right, my real solutions and my complex solutions. All right, so my real, we've already talked about. It's going to cross on the x-axis. So we've got 3 real solutions. That's pretty simple. Those are our real friends. Now, in order to figure out what's going on down here in this hot mess, remember, complex solutions do not touch the x-axis, and they always come in pairs. So I'm going to say that again for the people in the back. Complex solutions always come in pairs and never touch the x-axis. Okay, so what we're going to do is we see that there's this little hump that goes up and then goes back down. This is like a fake friend. Like, you're standing right here on the real axis, right? And you're like, hey, homie, and you go in for like a handshake, and he's like, swerve, and goes back away. Okay, so that is a fake friend, right? Like, he fake, he imaginary, he complex. So, but he's not just one person, he's actually 2 complex solutions. He's 2 complex, okay? So, how many roots do we have in total? Roots is the total number of real and complex. All right, so let's think about this. We got 1, 2, 3, 4, 5, because our fake friend counts for 2. So how many total roots do we have? 5. Okay? All right, so horizontal asymptotes and vertical asymptotes. Okay, so horizontal asymptotes run side to side. Remember, the horizon is where the sun sets, and it's horizontal. Okay, that's the most beautiful sunset you ever did see. And then vertical asymptotes are going up and down. Okay, all right, so let's say, for instance, we have t-shirts that we're trying to buy, and we can produce them. You know, we can produce one really expensive, or the more that we produce, the cheaper it's going to be to produce one of the t-shirts, right? Okay, like this often happens when you're buying like sports team shirts or whatever. Okay, so as you're increasing the number of shirts, the price per shirt decreases, right? It's coming down. It's yellow timber. Okay, so we're trying to figure out what this horizontal asymptote actually means. You see how it kind of like cuts off right here and goes on forever at this lovely value of y equals 4. I'm sorry. I don't know why I wrote 2. Y equals 4. We're trying to figure out what does that mean in context with this t-shirt and cost per shirt. Well, since we've got a horizontal asymptote running right there, that's saying that you can't go lower than $4 because that's how much it costs to produce the shirt. Okay, everything that's above $4 is just profit, right? If you sell them for $4, you're not going to make a profit though. You'll just cover the cost of the shirt. But if you charge like $8, you're making $4 worth of profit. Okay? Now, vertical asymptote's a little different. Okay? The vertical asymptote's a little different. So it's going straight up and down, right? Okay, so with that same mentality, let's say that it's coming down, blah, blah, blah. Okay? And let's say there's a vertical asymptote at 20 shirts. Okay? So like right here, there's a vertical asymptote at x equals 20. So that is telling us, so we're interpreting what that means. For vertical asymptote, that's telling us that it costs that much money. So it costs all the way up here to produce, and whatever your y value is in that case, to produce 20 shirts, we're going to start decreasing that price, right? So 20 shirts is